All right, so today, what? No. So today we're going to start in on a new section that is going to combine some of the stuff that we've done so far. The first section in the, I don't speak sign language, so.
What is this?
Oh, this is a microphone. I'm recording. We're going to make this into a YouTube video so that Shaylin, who's skipping, can watch it later. Yeah, now what I need to get working on. Anyway, so the beginning of the chapter we talked about the graphs of polynomial functions, and then the next bit we spent doing some algebra. What we're going to do is we're going to combine those two ideas, and we're going to use them to allow us to sketch the graphs of, to sketch the graphs of polynomial functions without using our like calculators or whatever. Just you didn't see anything, Landry, okay? All right, so this relates to the Desmos activity that we did on Friday. These were the kinds of problems that you were faced with on Friday in Desmos, but you did them the opposite way. You were given the graphs and then you had to come up with the equation. We're going to just start with the equation and come up with the graph, but the idea is the same. If I know that my polynomial is x times x minus 4 times x plus 3, what are the zeros of the function? In other words, what values of x will make the function equal 0? Yes. Okay, 4, because 4 minus 4 is 0, so 1, 2, 3, 4. What else did you say? Negative 3, because negative 3 plus 3 is also 0. 1, 2, 3. And also good. This one is easy to forget, but if you plug 0 in for x, then you're also going to get 0. So what that tells us is that our graph is going to cross the x-axis at negative 3, 0, and 4. Okay? All right, then we know if that's the only places that it's going to cross the x-axis, there's a limited couple of ways that the graph could be. It could either be like this, whoops, missed that a little bit, or it could be like, bless you, this. How do you know 2 ups or 2 downs? Say what?
No, because it's not negative.
So how do we tell? Remember what we did in the very beginning, the very first section of the chapter when we made that little chart? How can you tell, if it's, yes? She's using fancy words and everything. Yeah, so we need to look at the lead coefficient and we need to look at the degree of the polynomial, okay? Yeah, nicely done. So what would the lead term in this polynomial be? Just the first one if I multiplied it out. What would x times x times x give me? Yeah, it would give me 1x to the third, okay? So, based on the lead coefficient and the degree of the polynomial, what kind of polynomial is it? It's positive because the 1 is positive, and it's odd because the exponent is odd. And so, which way does that go? Does it go down, up, down, or does it go up, down, up? Up, down, up. Good. So now we know that the graph is going to look something like this. Okay? All right. Notice that we're estimating a little bit because I just sort of made these 2 humps just be a random kind of height. If I wanted to, I could take like 2 and plug it into here for x, and then that would be 2 times negative 2 times 5, and that would tell me that that one would be actually way down there at negative 20. But just as long as we have the general like shape of the graph, then we're good. Okay? Where did I get the what, where, when, and how? Oh, if I plug 2 into here for x, then that would be 2. And then 2 minus 4 is negative 2, and 2 plus 3 is 5. Okay? All right, does that make sense? You see how we're putting together some different ideas? Yeah. Oh, the reason that I plugged in 2 is because I figured if this goes through at 0 and then again at 4, then probably halfway in between is where like the lowest point is going to be. So I would just plug in 2 and then, yeah. What? Halfway in between those two? I'm going to go with no because things usually aren't always. But I don't really know. It's not important. All right, so let's try another one. So this time let's start with 4x cubed plus 4x squared minus 24x. And this time they have upped the... You okay? Okay. This time they've upped the difficulty level just a little bit because... Right, it's not factored. Okay? So we have to do that part of the job all by ourselves. We have to factor it. Okay? So, yeah. So, it's physics. Or is this what you're doing in physics? Okay, bye.
It doesn't really have high frequency.
What can you factor out of each term of this polynomial? What? 4x. Okay, so if I factor a 4x out of 4x cubed, what am I left with? X squared. If I factor a 4x out of 4x squared, what am I left with? Just plain old x. And if I factor 4x out of negative 24x, what am I left with? Negative 6. Yeah, way to strain the brain there a little bit. That was a tough one. 24 divided by 4. Woo, been a long weekend. Big brain. All right, but wait. There's more. If you call now, you get as a special bonus a, what? Okay, good. So this is going to factor into x plus 3 times x minus 2 because 3 times negative 2 is negative 6 and 3 minus 2 is 1, right? Okay, so now we have all of the information that we need to sketch a graph. Where will this graph cross the x-axis? What are the zeros of this function? Negative 3 because of the x plus 3. 2 because of the x minus 2. Remember, those are always opposite. And 0. Yeah, I was going to try to hit that note, but then I thought, nope, we are being recorded right now. 0! Nope. No, wasn't good. I don't know. All right, so then again, yes. Ooh, that's an excellent question because we're 2 for 2, right? So it seems like maybe if it happened twice, it's a tradition. It's going to happen always. Like when I used to coach golf and like we'd stop one time at this restaurant on our way home from a match. And then the next year the girls would be like, well, we have to go there again. It's a tradition. No, it's not. Not always. The only reason why these go through 0 is because there's an x by itself there with no number. Okay? The next one will not. Good question though. All right, what is the lead? Oh, well, we already know because they started out with the polynomial. Is this odd, even, positive, negative? Positive, because the 4 is positive, and it's odd. Sophie, Mason, don't get confused about whether you're looking at this or this to decide whether it's odd or even. You're looking at the exponent to decide whether it's odd or even. And so this is an odd positive, which means, yes, it does the same basic thing as the one before it. So that's not very exciting. Let's do an even positive, shall we, Sophie? Because if you look at the very next problem, what is it? It's even positive. So let's see what an even positive looks like. Yeah. Oh, right. So if you wanted to find this minimum point, A good guess would be if you plug 1 into the original function, so that'd be 4 plus 4 minus 24, that gives me negative 16, so this one is way stretchier also, okay? But we're not really concerned that much about that, okay? All right, let's do another one. Let's take a look at an even positive instead of another odd positive. So the first thing we have to do is we have to factor x to the 4th minus 81. And Taylor's expression might be what a lot of your brains are saying right now. How in the world do you factor that? You can't factor an x out of both of them because they don't both have x's. You can't factor a number out of both of them because this one only has a 1. What's that? Yeah, but it's like to the 4th. Fourth root them? Yeah. Okay. Okay, no, I want to factor it, okay? So I'm going to do a little trick here. What two things can go in front of these parentheses to multiply to give you x to the 4th? X squared. So instead of being an x and an x, because I need an x to the 4th, I'm going to go x squared and x squared, okay? And I could go x to the 3rd and x, but that's not how this works. And then what are my two numbers going to be to give me negative 81 when I multiply? Positive and negative 9. Awesome. Okay. So did we not talk about this before? This is the difference of two squares. Okay. Good. But this is a little bit hidden because normally we did like x squared minus 81, but we can do it with x to the 4th. You could do it with x to the 6th. Any even power of x will work. Okay. Okay. Yeah. There's more. Okay. Just like this one over here, we could take it one step further. Which one of these two things, or maybe both, can be factored into what? What else can I do? Okay, this guy right here, the x squared minus 9, I can factor into x plus 3 times x minus 3, right? Okay. Well, they're not both the same. So they can't factor into the same thing. That's not possible, right? Because what I'm saying is when I multiply these out, I get x squared minus 9 as an answer. I'm not going to get x squared plus 9. What does this factor into? X plus 3 and then x plus 3, because 3 times 3 is 9. But then you also get 3 plus 3 is 6. So that would be x squared plus 6x plus 9. What did you say, Levi? Yes, good. That's excellent. We would have to use imaginary numbers. And since we are just sketching a graph, so we want the actual real numbers, we're not going to go there yet. Okay? We'll get there soon, though. So, as it turns out, this graph only crosses the x-axis in two places. Where are they? 3 and negative 3. And then this is an even positive. So what does it do on either end? What's it? Yeah, good. This is like a touchdown Seahawks graph. So it's going to look like this. It's kind of like a parabola. If I were to graph this on Desmos, you would see that the bottom of this parabola is a little bit flatter than a normal parabola. The higher this exponent goes, the flatter that becomes. Sophie?
How do you get the positive or negative? If you understand
The number in front of the highest thingy, so this is positive, okay? Isa?
why doesn't this one go to 0?
Because, yeah, turning it down a little bit. Because if I plug in, oh, did she just, nope, okay. Because if I plug in 0 for x, I don't get 0 as an answer. If I plug 0 into here for x, then 0 to the 4th is 0. 0 minus 81 is negative 81. So that actually means that this y-intercept way down here is negative 81. If I plug 0 into here, 4 times 0 cubed plus 4 times 0 squared minus 24 times 0 is 0. So that works. And same thing here. If I plug 0 into this, that would be 0. That's negative 4. That's 3. That would also give me 0.
So it tends to all equal 0.
Yeah, and the way that you can tell is that, and this is what I think that Haley was asking, about is this is a x all by itself. So that's how you know that 0 will work. It's not plus or minus anything. And when we factored this, this was an x all by itself, not plus or minus, but I didn't get one here. Okay? All right, how do you feel about that?
Nope, great. Yeah.
Good?
I like it.
Okay. All right, so that's pretty simple. The fun part is to start talking about what's called multiplicities of the zeros. And this is going to be muy importante for what we do in el futuro. Is that just yeah? Probably not?
Yeah.
Okay. And this is the stuff that you kind of were getting into on Friday with the Desmos activity, was a little introduction to this. Sometimes when you make a graph, the graph does some funny things right at the x-axis, and we talked about that on Friday. If you have a graph that goes and it hits the x-axis in a parabola sort of way, what did I tell you you had to do to make that match? Right, we had to make this into like an x squared, okay? So what we would say is that this 0 has a multiplicity of 2, okay? That 0 comes up twice somehow. So you guys were writing it as like x minus 3 squared, but you could also write it as x minus 3 times x minus 3, which would give you the sense that it has come up twice. Then I think there was one that maybe not all of you got to, and it had a graph that went through the x-axis, but it did it in kind of a funny way. Does anybody remember what this came out to be?
Kind of crazy. It was like the third.
It was to the third. Yeah, good. Okay, so this would be some sort of an x cubed thing, and so in that case, we would say that it has that 0 has a multiplicity of 3. Okay? What's important for you to understand is that if a 0 has an odd multiplicity, the graph will go through the x-axis at that point. And if a 0 has an even multiplicity, then it will like hit the x-axis there and then bounce off. Okay? It won't go through. Yeah, absolutely. So I can take this and I can make this as funny as I want it to be. So if I go, I will momentarily. So if I go x plus 2 squared, then you can see that it just hits right there and bounces off, right? I can take this, as long as I keep this as an even number, I could make this to the 4th, and it will still hit right there. Okay? Yeah, and what happens, like I said before, is as this exponent gets higher and higher, it still does the same thing as long as it's even, but it gets to start looking more and more square on the edges. Now, if we zoom in, we can see that it's not actually square there. It's always still going to be curved. I just have to find it. There we go. Okay. So you just have to zoom in close enough to see that it still always does have a curve there. Okay. And you guys know that because if it went straight up, then it wouldn't be a function. It would fail the vertical line test. But the point is, as long as my exponent is even, it's not going to go through the x-axis. It's just going to hit there and then bounce off. Whereas if my exponent is odd, it's going to go through, okay? And again, I could keep making this into larger and larger odd numbers, and it would still go through there in a dork here and dork here way, okay? So this part here is really important, this second little paragraph. When the multiplicity of a 0 is odd, the function crosses the x-axis. When the multiplicity of a 0 is even, the graph has a turning point right there on the Michaela. You know there's no assigned seats here. You can sit wherever you like. You don't have to sit next to... Yes. Yes. Are you excited?
Yeah.
No.
It's an angry fish. It's an angler.
It's an angry angler fish.
I am saying angry.
All right, so here's some examples of these different... Oh, go back still? Yeah, okay. All right, so you can see some examples of this. This one right here, what's the exponent there? 1, good, which is odd. So that means that the graph crosses the x-axis at that point. What's the exponent here? 1, which is also odd. So the graph crosses the exponent at -2. The exponent right here is 2, which is even. So that's why the graph has a turning point right there. Okay? And then the exponent here is 1, which is odd. So that's why it crosses the x-axis. Same deal here. This one has an exponent of 3, which is odd. So it crosses the x-axis there. And you can see it does it a little bit differently than over here because it's a 3, not just a 1. And then over here we have it to the 4th power. So it has a turning point right at that 0. Okay? Make sense? Okay. So if I were to give you this factored polynomial, first you would need to tell me what the zeros are of this polynomial. Okay, 0. And again, Isa and Haley, this is the reason why there's a 0 is because it's just a plain old x. Okay, so that's 0. X equals what? It would still just be 0. Yep, it just needs, as long as it doesn't have a plus or a minus, it's going to just be 0. What 0 do I get right here? -4. And what do I get right there? +1. Okay, we knew that already. We knew that weeks ago when we were dealing with quadratics. What does the graph do at this 0? Does it cross or does it turn? It crosses because this exponent was 1. So right here it crosses the x-axis. Okay? How about at the 0, x equals -4? Why? What's even? Oh, no, but we're not worried about the number itself. We're worried about the exponent that goes with the number. So if I look at this factor right here that gave me the -4, right, this is to the 1st power, which is odd. So the graph will also cross the x-axis at x equals -4. And then what happens at x equals 1, which comes from here? Right, that one has a turning point at x equals 1. Okay? Because the exponent that gave us this 0 is even. So don't be confused. We're not talking about whether the zeros themselves are odd or even. We're talking about the exponent that goes with the factor. Okay? Whether that is odd or even.
So 4 goes with that one.
So 4 is even, so that's why it's a turning point. Okay? All evens are turning points. All odds are crosses. Okay? Okay. What are my zeros for this function?
3.
What? Mason. Are you looking at this right here? Okay, if you plug 3 into here, 3 squared is 9. 9 plus 9 is not 0.
-3.
Well, -3 is still just 3. What? Right, but we're not.
Factor that one. So,
What does x squared plus 9 factor into?
x plus 3 and x minus. Oh, x plus 3 and x plus 3. So it's
Nope. X plus 3 times x plus 3 does not equal x squared plus 9, because then I would have a 3x and a 3x. Yeah, so this gives us nothing, okay? There's no 0 there. We'll talk about that. Levi has pointed out that we're going to need imaginary numbers for that, but imaginary numbers don't make anything on the x-axis. What about this guy right here? Positive 1, and since that has an odd exponent, that is going to cross the x-axis there. Okay. What's going on right here? Negative 2, and since that has an even exponent, that is going to be a turning point. Okay? So again, important part to understand there is that if it is an odd exponent, it crosses the x-axis at that point. If it's an even exponent, it's a turning point. Okay? Okay? A-okay. Yeah, well, you know. All right, so now we're going to bring Levi's fun into play. And we're also going to bring synthetic division into play. This is totally awesome. I just love this, okay? So this says, what are all the real and complex zeros of the polynomial function shown in the graph, okay? So what we do first is we look at this and we say, where does that cross the x-axis? At 2. So you know that's one of the answers, okay? So what I'm going to do is I'm going to put 2 in the box. Notice that I did not switch that around and make it negative 2. If I was going to write it as a factor, it would be x minus 2. But if I'm, doing synthetic division, it just is a 2 that goes there. And then I'm going to go 1, 1, negative 3, negative 6. Because those are the coefficients of the terms of the polynomial. Yeah. I got the 2 because it crossed the x-axis at 2. Okay. That's an excellent question. If it crossed more than once, then I would do this more than once. And we will do that soon. Okay. All right. And then I'm going to go synthetic division here. So I'm going to bring the 1 down. 2 times 1 is 2. Add those together and I get 3. 2 times 3 is 6. Add those together and I get 3 again. 2 times 3 is 6. Add those together and I get 0. Okay? All right, so now I need to find 2 more zeros. The way that I'm going to do that is I'm going to use these numbers right here, the 1, 3, and the 3. I know, without even trying, that this is not going to factor. Why? Not even thinking about these numbers at all. How do I know from looking at the graph that this will not factor? Right. I mean, you know that there's no 2 numbers that multiply together to be 3 and add together to be 3. But how can I tell that I don't even need to think about that from looking at the graph? Haley? Yeah. It only goes through the graph once. So that means I'm only going to have one real answer. Okay? And the other ones are going to be imaginary. So I'm going to go straight to the quadratic formula from here. So my other 2 answers, the nice thing about this is it's set up for you A, B, and C. Okay? The way that these numbers came out. So if I'm going to use the quadratic formula, I'm going to go opposite of B plus or minus the square root of B squared minus 4AC. Then you take that total and divide it by 2a, which would be 2. And that's the quadratic formula, and Haley's really happy today. Yeah, we're doing the quadratic formula song in the talent show. Yeah. In just like half an hour from now. That's why she's pumped, because she's getting ready. Do a little duet, and then we're going to do a sing-along, and then we're going to do a round with the whole people. We're going to be like, all right, freshmen, you start first, and then sophomore. Yeah. Yes, exactly. So, okay. So if I simplify this, I get negative 3 plus or minus the square root of negative 3 divided by 2. This
Can't do it.
should not be unexpected because we already decided this is the only real one. The other ones were going to be imaginary. Okay? So that means all I have to do now is go negative 3 plus or minus I square root of 3 over 2. Okay? And so my three answers, x equals 2, because it hits at 2, and we checked it with synthetic division. We know that it works. Negative 3 plus I root 3 over 2, and negative 3 minus I root 3 over 2. Jared? Yeah, you should get to this far. What you don't have to do is if this like came out to be 12, and then we're going to simplify the square root, you wouldn't have to do that. You just leave whatever numbers under there. But yeah, just change that into an I, and you're good. Okay? All right? So those are our answers. All right, let's try, looks like 2 more. Okay.
3?
Yep. But say it with confidence.
3.
There you go. You know, since this is crossing the x-axis at 3, that 3 is one of our answers. Okay? Now I'm going to find out what the other 2 are. And I'm going to do that by first using synthetic division. So 2, negative 8, 9, negative 9. Bring down L2O. 3 times 2 is 6. Negative 2, negative 6, 3, 9, and 0. Okay? This one only crosses once. X-axis, one time. Yep, okay. So we're good. So now I'm going to go quadratic formula from here. This is A, this is B, and this is C. So to do the quadratic formula, I'll take the opposite of B, so that's 2. Plus or minus the square root of. Remember that even though this is negative, a negative number squared is always a positive, so that's going to be 4. B squared minus 4 times A times C. Then you take that all over to A. Okay, so, whoops, that's not a plus or minus in there. Sorry. That is just a minus. All right, what's 4 minus 24? 20. Negative 20. Okay, so Jared, this is where you get a little bonus. This comes out to be 2 plus or minus negative 20 divided by 4. You can just change this to an I and then stop there. Okay? But these crazy kids have to simplify this square root of 20. What's the number you know the square root of that goes into 20 evenly? 4. So I'm going to go 2 plus or minus the square root of negative 4 times 5 divided by 4. And then what is the square root of negative 4? 2i, because it's negative. That's important. So 2 plus or minus 2i root 5 divided by 4. And then what do you notice about all these numbers outside the square root? They're all even, so I can reduce those. 1 plus or minus I root 5 divided by 2, which you can also split that up into 2 fractions if you want and go 1/2 plus or minus I root 5 over 2. That's the same thing. All right? Okay, I got to do one more because Haley asked what if it crosses more than once, or maybe it was Taylor, I can't remember, or it could have been Sophie. This one crosses more than once, so let's do that one real quick, and then I'll give you some problems to work on your own. Okay, so where does this one cross the x-axis?
2 and 8.
Okay, which one do you want to do first? Negative 2. All right, so I'm going to go negative 2. Be careful with this one because I have, right, good. I have 1x to the 4th, and then don't forget, Landry, I have 0x cubed, so I need a 0 there. And then I have negative 3x squared, and then 0 x's, and then negative 4. Okay? So those zeros are important. Don't forget to fill those spaces in. All right, I bring down the 1. Negative 2 times 1 is negative 2. Add those together, negative 2. That's going to give me 4, 1, negative 2, 4, and 0. All right, I feel like there was someone in here that I shared this clue with, or maybe it was all of you guys. Okay, now we're going to do 2, right? Was it you? Okay, that's right, it was you. But I'm not going to go back to the beginning and do 2 with these numbers all over again. What I'm going to do is I'm going to do 2 with the numbers that I have left over. This is called the repressed polynomial, when I take this and then I go one step down. So I'm just going to use the repressed polynomial because I want it to get smaller and smaller and smaller. I want fewer and fewer numbers, okay? So now I'm going to bring down the 1. 2 times 1 is 2. 0, ooh, I like that. 2 times 0 is 0. 1, 2 times 2 is 2. And then that works out to be 0, okay? And the reason why this is handy is because what was the exponent of my starting polynomial? 4, which means this one is 3, which means this one is 2. I'm going down by 1 each time, okay? So I could, if I was Haley Bradshaw and I'm really excited about the quadratic formula, I could use the quadratic formula right here, but I don't have to because this is really x squared plus 1 equals 0, right? X squared plus 0x plus 1 equals 0. So this is super easy to solve. How do I solve this? Math magic, yeah. What math magic do I use to solve this?
Algebra.
Minus 1 from both sides, so x squared equals -1, and then square root both sides. So x equals plus or minus the square root of -1, but you know the square root of -1 is I, so x equals plus or minus I, okay? So, hang on, just almost there. So my 4 answers for this are -2, because it crossed at -2, 2, because it crossed at 2, and then when I took what was left and I solved it, I also got plus or minus I, okay? And I could have done these in either order, and it still would have worked out the same, okay? Yes?
Why didn't you include the last 0?
Oh, because that's just the remainder, and when the remainder is 0, then we can just throw it out. So the last one nobody cares about.
It's not like x squared, x, 1, 0, and then that's...
And then some other weird random like 0.10 or something? No, it's not a thing. Okay, yes? How do we know how to graph that? Didn't we just... Oh, yeah. No. Yeah. Okay, that's a really good question. If the remainder was not 0, we did something wrong. Okay? Either we made a mistake in these steps here, or the book was being mean to us and it doesn't actually cross at 2, it crosses at like 1.9. Okay? But it should work out. Okay. All right? Okay, the secret word is grasshopper milkshake. I guess that's more than a word. So, Shaylin, if you're listening at home, if you come in tomorrow and say grasshopper milkshake, then you get some dojo points, but we'll see. Okay, I didn't.